Alright, we are applying properties of similar triangles. So I'd like you to copy these notes. We have triangle ABC. Please copy one similar to that. Okay. And let's say we have a line that's going across so that it is parallel to BC. So we have two intersections, E and F. We're going to find that we can make proportions from this. It's going to be AE over EB equals AF over FC. You'll see that, here we go, AE is here over EB equals AF over FC. Now maybe you'd prefer to see that with some numbers. So sketch another triangle. Again, we have a line parallel to one of the sides of the triangle, and it intersects the other two sides. We'll call the sides length 4, 3, x, and 5. And again, we're going to see if we can set up a proportion, and there you go. 4 is to 3 as x is to 5. So this is called the triangle proportionality theorem, and you'll definitely want to write that down. Feel free to pause the video at any time if you need me to slow down. So it says that if a line parallel to a side of a triangle intersects the other two sides, and we can see that that is the case for both of these. This line here is parallel to BC as indicated by these red birds on a wire. Again, parallel to this, indicated by red birds on a wire. And that's exactly what the hypothesis is that we have here. Parallel to a side of the triangle, and it intersects the other two sides. And up here you can see those intersections we labeled as E and F. Down here they would be, here is an intersection and here is an intersection. So what is the conclusion? Then it divides those sides proportionally. And then we'll look at an example. Our conclusion divides those sides proportionally. So we can recall that anytime we have ratios that are equal to each other, that is proportionality. Notice the pattern. It's this over this is equal to this over this. It is crucial that we have a parallel line going on in here. Alright, let's look at an example, and I'd like you to copy it down and complete it with me. We're going to find CY, the length of CY. What is CY? Okay, well there we go. There's our parallel line or line segment. But this time, what's different about this parallel line compared to the other examples? Which side of the triangle is it parallel to? It's actually parallel to CB this time, not the base. We'll indicate that by putting birds on the wire. And we'll give some lengths here, 4, 9, and 10. Those are arbitrary lengths that are given. And of course, we're trying to find the distance from C to Y. So how are we going to do this? Well, we are going to use but we just learned about making proportions from this scenario. Okay, so we set up our two fractions that are equal to each other, and I started off with the 9, and you kind of have to turn your head on the side to be able to see this because it is very different than what we were just looking at as far as its orientation. So I have a 9 is to 4, and then we'll do as 10 is to cy. Nine is to 4, as 10 is to cy. And of course we're going to cross multiply once we have that. We're going to simplify. 4 times 10 is 40. And then why don't you go ahead and do the last step to solve. We should do what to both sides? Divide. On the left side, they cancel out. We're left with cy is equal to 40/9, or what would that be as a mixed number? How many times does 9 go into 40? It's got to go in there at least 4 times, because 4 times 9 is 36, so how many remainder units do we have? 4/9. So 4 and 4/9. Okay, so I'd like you to go to page 482, copy and complete. Check it out, number 1. Show all of your work, and we will go over that tomorrow in class. Thank you, and have a good night.